Hello, welcome to this Amazon EC2 Masterclass. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe, and I'm going to be presenting today's session. And I'd also like to introduce Adam Boglin, a member of the AWS Solutions Architecture team from the US, who is going to be handling the Q&A at the end of today's session. So let's kick off with today's Amazon EC2 Masterclass. The Masterclass series is a series of technical webinars where we deep dive into specific AWS services that are intended for intermediate to advanced users of these services. And they're really aimed at showing you how to get things done with the service, incorporating presentation material together with demos. And today we're going to be focusing on EC2, a service that provides resizable compute capacity in the AWS cloud, enabling you to run virtual machines, which we call instances. And it's designed really to make web-scale computing a lot easier, providing a virtual computing environment where all of the resources can be controlled via software using a variety of different AWS interfaces. You can launch instances or virtual machines with a variety of operating systems, and it's an elastic on-demand service that enables you to run as much or as little resource as you require for your particular use case. The service has some fundamental characteristics in that it's easy to control, very flexible, operates at a variety of scales, including the very large, has reliable and predictable characteristics, it's secure, inexpensive, and easy to start. And in most cases with the Masterclass webinar series, I'd include a variety of different use cases here. The problem with EC2, the challenge with it really is, there are so many different use cases that you can put this particular service to that it's almost impossible to state them all on a slide, so I didn't bother. You can use it for everything from running high-performance game servers through to HPC, video rendering, enterprise applications, databases, web applications, APIs. There's just so much scope there. Basically anything that you can apply an Intel CPU and an operating system to, you can run on the EC2 service. The service has been around a long time. It was launched back in August 2006, and the 10th birthday for EC2 is coming up in August this year. The news of the launch was originally announced by Jeff Barr, the chief evangelist at Amazon Web Services back in 2006, and I doubt very much that he figured I'd be showing his holiday photos 10 years later on a webinar talking about EC2. The service when it was first launched was pretty simple, with a single machine type with pretty modest resource allocations. And over the course of the last 10 years, we've added a lot of different types of EC2 instances to the service to enable customers to run a variety of different workloads. And we'll talk about many more of these instances later in today's session. We've also focused on feature innovation with the service and have added a great many new features to the service. And we continue to do that even today. If you visit awsamazon.com/new, you'll find a compute section there on the new services page on the AWS website. You can check out recently announced EC2 features at any point by doing that. The agenda for today's session that we're going to cover, first of all, we're going to talk about EC2 concepts and fundamentals. Then we'll take a look at storage and networking with EC2, monitoring, metrics and logs, security and access control, deployment, and lastly we're going to focus on cost optimization before, of course, taking a few questions live at the end of today's webinar. Let's kick off with a look at these EC2 concepts and fundamentals. Let's start with regions. These are the geographical locations around the world where Amazon EC2 will create the instances that you choose to launch. We currently have 13 regions, and the most recently added region is a new region in Mumbai in northwest India, which we added just a few weeks ago. Customers will select regions on the basis of three criteria, really. They might want to place their EC2 resources in a location where latency is optimized for access to applications by users, or they may wish to optimize latency to other data resources that they've already got stored within the AWS cloud. So that can be another latency-based reason for choosing one specific region. There are also cost variations across different regions, which really reflect the fact that AWS wants to pass on the minimum amount of cost to customers that choose to use our services. And if we can reduce the cost of operations in one region in comparison to others, we will minimize costs. And this means that there is variability in pricing for the same EC2 instance type across different regions. And you can find full details about pricing variations on the EC2 pricing page. The third reason that customers might select a specific region is to do with regulatory and data sovereignty requirements. So you may need to store data, for example, within the EU for certain reasons, or for other reasons in other territories or geographies around the world. And you can also make use of regions for that reason. Each region is organized into availability zones. An availability zone is a logical grouping of data centers, and these provide distinct locations for you to launch your EC2 instances and other AWS resources that take advantage of them. And they're insulated from failures in other availability zones. So this means that data centers in separate availability zones will not share power, will not share network connectivity, and often are located in physical locations that separate them from things like flood or earthquake risk, depending on where the regions are in the world, of course. We provide low latency, inexpensive network connectivity between availability zones in the same region, and there's no charge for traffic that is inter-AZ and intra-region. And regions around the world have variable numbers of availability zones, but between 2 and 5 is the current range. So, for example, in EU Central 1 in Frankfurt, we have 2 EC2 availability zones, and in US East 1 in Virginia, we have 5 EC2 availability zones. When you launch your compute resources, launch your instances, you select which subnet you're going to place them in, having pre-created those subnets in specific availability zones, and that's how you do the placement. And the instances themselves are the units of compute capacity that you're going to take advantage of, that you're going to create. And they have varying combinations of CPU, memory and storage capacity, and also varying networking capacity in terms of bandwidth, budget, and packets per second throughput capabilities. Okay, so those are some concepts that we're going to return to later in today's session. Fundamental characteristics of EC2. As we said a few moments ago, it's available in different locations. There's an always up-to-date list of these locations available at the URL that you can see on the bottom right of this slide. We have support for a wide variety of different operating systems. The currently supported operating system list can be found in the EC2 FAQ, the EC2 frequently asked questions, which you can find at the URL that's bottom right here. AWS maintain and distribute several different operating systems, several different Linux variants, as well as several different variants of Windows. And there are also third-party provided operating system images available in the AWS Marketplace. AWS Marketplace also includes other commercial and open source software. Around about 2,500 different ISV products are present today. And these range from high-end commercial software products right the way through to open source development and application environments that you might want to take advantage of. It's an excellent way to access software that you want to run on your EC2 resources. And if you're not familiar with it, I really would advise checking out the marketplace and taking a look at some of the products that are available there for both trial and also for ongoing usage of them in production. EC2 is integrated with a variety of other AWS services, and actually several other AWS services also depend upon EC2 or are built on EC2. So that includes things like EMR, RDS, and Redshift. They all make use of compute resources to provide higher level abstracted services, but those compute resources are essentially derivatives of the EC2 service offering. The services that we see here, the Elastic Block Store, CloudWatch, VPC or Virtual Private Cloud, and IAM, we're going to return to these specific integrations later in today's session, and we'll learn a little bit more about them as we talk you through some of the other content that we have for you today. There are several different purchasing options for EC2 capacity. On demand, which is the familiar by the hour, no commitment model that many of you will be familiar with, but also reserved instances where you can pre-purchase, pre-commit to EC2 capacity over a longer period of time, over a 1 or 3 year period. And this unlocks significant hourly discount rates in comparison to on-demand pricing. Again, we'll return to that at the end of the session when we talk about cost optimization. And there is also an EC2 spot market, which is another commitment-free model. And again, we'll return to that and talk about it in more detail later in today's session. You can import and export virtual machines to and from other virtualization environments into the EC2 service, and we provide a specific service for this called the EC2 VM Import Export service. Further details at the URL that you can see on the bottom right of this slide. But this allows you to import your VMware VMDK files, convert them into Amazon Machine Images or armies, and then launch instances from those armies. And customers use this both as a component of migration strategies to move to the AWS cloud, and also in regular activities such as disaster recovery planning, where you might periodically import virtual machine images and have them ready to go in AWS to protect you from disasters that might impact on-premises or other environments that you're currently running. So that VM import-export is a very useful feature from that perspective. There are a choice of different instance families with differing resource ratios. And the nomenclature, the naming of these instances looks a little bit like this. So here we're looking at an I2 X large instance type. So second generation indicated by I2, the type indicating the size essentially of the particular unit of compute capacity that we're going to use, and then the family in the brackets. So this would be a storage optimized instance. These I2 families actually have a large amount of internal solid state disk installed within the machines that host the instances. And this can make them excellent for things like non-relational databases and the like. So that's an example of how instances are named. And I just wanted to focus in on a few different instance types to talk about some of the differing characteristics. So the T2, these are low-cost EC2 instances that come with burstable performance. We originally announced them in July 2014 when we announced several different derivatives, the micro, small and medium T2 family instances. And the way that these instances work is they come with a fixed CPU allocation. You can see that in this middle blog post from June 2015, where we announced the availability of an additional T2 instance, the T2 large. And you can see in the third column of that table there what the baseline CPU performance is that is offered with each of these different sized T2 instances. So taking the T2 micro, the baseline performance would be 10% of a single CPU. Okay, and we manage that by allocating CPU credits. So you can see there you would be accruing 6 CPU credits per hour, which equates to that 10% baseline performance figure. If you're not using those 6 CPU credits per hour, so say you were only operating at 5% of a CPU rather than 10%, those 3 additional unspent CPU credits per hour would end up in a bucket, essentially saved for you. And if you did need to burst above that 10% baseline performance level, as long as you had sufficient CPU credits per hour to draw those down and burst your CPU, you'd be permitted to do so by the service. So they're an excellent fit for workloads that are extremely bursty in nature. This is actually makes them a great fit for things like continuous integration environments. Actually, for many web or API services, they're also a good fit for that. At the other end of the spectrum, we have the C4s. These are the highest performing compute instances that AWS offers today. They're based on the Intel Haswell v3 CPUs. We provide large allocations of vCPU capacity with the larger instances. So the C4 8X large would give you 36 of these Xeon v3 cores. 60 gigabytes of memory, and we expose some of the advanced features of the Xeon v3 in this instance family. So things like the AVX2 instruction set, which is intended to accelerate performance for floating point intensive applications, as well as the AES cryptographic extensions. They're exposed to you via the hypervisor. You can take advantage of these CPU features in your applications as long as your compiler supports them, obviously. So that's a very useful instance for high-performance computing and other CPU-intensive workloads. In May this year, we announced general availability of the X1 instance type. This is a high memory instance, which includes almost 2 terabytes of DDR4 base memory per instance. This is 8 times the memory of the preceding largest instance, which was the R3 8XL. Now here, once again, we provide 4 Intel Xeon E7 v3 Haswell processors with 128 vCPUs of compute capacity. This instance family is intended for large-scale in-memory workloads such as SAP HANA and other large in-memory database and analytics workloads that you might want to run. And when launching this instance, we also announced a new network adapter type called the ENA, or Elastic Network Adapter, which offers 20 gigabytes per second of network bandwidth. This is coupled with a new open source driver that we've released in order to support this new network interface type. And in addition to that, the X1s also come with 10 gigabytes per second of dedicated bandwidth to Amazon Elastic Block Store EBS at no additional cost. So as I said, these are really good targets for running large-scale in-memory workloads such as SAP HANA and other large database and analytics tasks. We're now going to take a look at other control options that are available to you. First one we're going to focus on is creating instances with the AWS CLI. This is the command line interface for AWS. It's available on a variety of platforms. Simple to install, and you can find instructions on how to install the AWS CLI on the website. If you check out the URL that's at the bottom right of this slide, you can find a command reference section that relates to the EC2 subcommand. So subcommands are the token that follows the AWS CLI itself when you execute a CLI command. So in this case, AWS is the CLI, EC2 is the subcommand, and run instances is the action that I wish to call against that subcommand. And here I'm specifying attributes. They're actually the same as the attributes that were specified in our console execution process earlier. So a machine ID, the instance type that I wish to run, how many instances I want to create, the security group ID that I'm going to apply to them, the subnets where I'm going to launch them, and the key pair that's going to be applied to them. So it's very simple. I hope you can see the similarity there between that CLI command and the web-based console action that we carried out before. There's detailed help available to you within the CLI in addition to the detailed help that's available in the web documentation. So here you can see the effects of typing AWS EC2 run-instances space help, give you back this help page, and that has within it a comprehensive list of all of the options available to you for whatever CLI subcommand you are executing. That's a really good way to learn more about the AWS CLI, actually, is to take a look at the embedded help. In addition to the CLI tools that we provide, AWS also provides 11 different SDKs that you can use to control AWS services. 10 of those are GA, and the 11th is a C++ SDK that is currently in developer preview. Here you can see some examples of working with EC2 resources using the Python Boto3 SDK. In the top command sequence, you can see that I'm importing the Boto3 module. I'm creating a client object in the EC2 API scope, and then I'm executing the run instances method against that client object, passing in some attributes that reflect the same attributes that would have been passed in via the CLI commands that I showed in the last few slides. And here we're going to create that group of 5 instances, and then I show an example of operating using the same API structure using the Terminating Instances method, passing in instance ID as an attribute, and then printing the response object that I create from that, which shows you the HTTP status request code, the request ID, and the response message stating that that particular instance ID is being terminated. And in the final example here, we're using the resource-based API structure. So we're creating an instance object, which is a Boto3 resource, again in the EC2 API scope. And then we're able to operate using methods on that instance. Here we're calling the terminate instance method, and that is being called with a specific on a specific object that's been created for a specific EC2 instance identified via its instance ID. And again, we're getting that terminate state back there, illustrating that instance has been terminated. Hope that gives you a flavor of how you can work with EC2 using the Python SDK. And obviously, if you're developing software using one of those other supported languages, then check out aws.amazon.com/tools. You'll find all the SDKs available for download right there. Next thing I want to take a look at is storage options. Obviously, compute resources are great, but compute resources are normally used to operate on data. You need to store that data somewhere. So what options are available to you for storage with EC2? There are 3 different options essentially. The first is instance storage. And instance storage is the locally attached storage that is connected to the host computer which is hosting your EC2 instance. This means that it's ephemeral in nature, will not survive instance stop and start operations or instance termination. We'll talk more about that in a few seconds. Additionally, you have EBS. This is the Elastic Block Store. These are network attached block devices that can be connected to EC2 instances. Their life cycle is independent of the instance life cycle. And these EBS volumes can additionally be backed by snapshotting. When you take a snapshot of an EBS volume, it's stored in a hidden S3 bucket. It's accounted for, and the capacity used is built to your account, but you cannot see the snapshots via the S3 console. But they do benefit from the familiar 11.9's durability, which is provided by S3 at a regional level. They also maintain data locality in that specific region, so your snapshots will not be moved out of region for the reasons of protection. And you can then create armies from those snapshots, essentially creating new images that you can use to create new instances from, or you can create new volumes from those snapshots and you can reattach those to running EC2 instances. And that's a common methodology that customers use for data backup and recovery with EC2. So we're going to dive into these storage options in a little bit more detail now. I'm going to focus here on the difference between instance storage and EBS. And as I said a second ago, instance stores are physically attached to the computers that host your EC2 instances. The type and amount differs by instance type, and you might recall in our console walkthrough earlier, talked about how that M3 medium had 4 gigabytes of locally attached instance storage on the SSD media type. Well, if you scroll down the instance list in the console or check out the EC2 instance detail page, you'll find there full details of the instance storage that's provided with each different instance type. And as I said earlier, the data stored on instance stores is dependent upon the instance lifecycle. Because stopping and starting an instance and of course terminating an instance will mean that your instances are no longer necessarily on the same hardware, we can't guarantee that the instance storage will be available for you through a stop-start operation, and for this reason we do erase instance storage through the stop-start operation, so it's not persistent in that sense. EBS is different in that it is persistent level block storage volumes. There are several media types available to you: magnetic, which is based on rotational hard disk drives; general purpose and provisioned IOPS. They're both based on solid state disks on SSDs. The difference here is that general purpose comes with a fixed IOPS allocation, whereas provisioned IOPS, you can dial in a specific level of IO which can match your particular workload profile. Data here is independent of the instance life cycle, as we said, and I'll explain a little bit more about that in a moment. So, instance stores, as we said earlier, they persist if the instance is rebooted or restarted. They do not persist through stop, and they do not persist through termination. They can also be lost if an underlying instance drive fails, so they shouldn't be regarded as having the same durability characteristics as EBS volumes, because they do not necessarily have that. And for this reason, customers that are using instance stores for data that needs to be protected, commonly replicating data in the instance operating system or in the application net they're running on the instance in order to make sure that it's protected, if indeed protection for that data is required. EBS volumes, in contrast, they're automatically replicated within the availability zone in which they're created, and they are roughly 10 times more durable than commodity hard disk drives. So you're going to see a boost in availability and durability of your volumes because of this replication feature. This also means that there is literally no point using RAID 1 or RAID 5 volume protection with EBS volumes. We're already performing that function in the infrastructure, and to do so is just an unnecessary overhead in terms of cost for the storage that you'll consume and also cost for the CPU load that will incur, so do not do that. EBS optimized instances are a specific instance type which once again, or a specific characteristic of certain instance types, which once again you should have seen in the instance console walkthrough that we did, instance launch console walkthrough that we did. And here we provide a dedicated channel for connectivity from the instance to the network attached block devices, and depending upon the instance type, you can drive between 500 and 4,000 megabytes per second via the dedicated channel for EBS optimized instances. So you can achieve very high levels of storage performance using EBS optimized instance types in conjunction with PIOPS volumes. The volumes that you attach to a running instance during its lifetime will automatically detach with their data intact at the point of termination. Volumes created and attached to an instance at launch are deleted when the instance is terminated. You can, however, change that during the instance's lifetime by changing a flag on the volume named delete on termination, if you change that to false, then volumes will not be deleted at the point at which the instance is terminated. So you can modify that behavior during the lifecycle. So we said earlier, you can support backup and protection of EBS volumes using snapshots. And this is a snapshot chain that is created when you do this. So the first snapshot that you take will copy all of the blocks on the volume into Amazon S3. Then we used change block tracking technology so that each time you take a subsequent snapshot, only change blocks will be copied to the snapshot volume. And obviously when you restore from a specific snapshot, all of the blocks associated with that particular snapshot will be recovered right back to the root snapshot that you originally took. And if you delete a snapshot, only data that is exclusive to that snapshot is removed by virtue of the fact that this hierarchy, this chain of snapshots is maintained in the back end. These snapshots can be shared across AWS accounts, and they can also be copied across regions, and they're commonly used for making copies of systems in other regions if you want to protect data there or instantiate systems in remote regions. There's an EBS encryption option that can be turned on EBS volumes. When you do this, all the data stored at rest on the volume, disk I/O and snapshots created from the volume are all encrypted. This is because encryption occurs on the servers that host the EC2 instances, provides encryption of data in transit from the EC2 instance back to the EBS storage infrastructure across the network. EBS encryption makes use of the KMS service. This is the AWS Key Management Service for master key storage. You can also optionally create your own custom master keys within the key management service and nominate these as the keys that you will use for volume encryption when you create new volumes. If you do this, it gives you the ability to create, rotate, disable, define access controls, and also audit access to those keys. That's an important feature for certain customers operating in regulated industries where specific requirements for compliance must be met. The last thing to say on EBS is that we have new, larger, faster EBS volumes available now. These offer 16 terabyte volume sizes, and they offer the performance characteristics in terms of IOPS and throughput that you can see on the slide here. This has also simplified the process for customers that are managing large volumes because there's no requirement to manage volume aggregates to provide volumes up to 16 terabytes in size. Next thing I want to show is a quick demo of working with EBS volumes via the console. So let's jump over to the EC2 console now and do that. I'm in the volumes section of the EC2 console here. You can see the 5 volumes that were created earlier, those 16 gig volumes that we created when we launched those 5 EC2 instances in that prior demo are here. And I just wanted to quickly show you the process for creating new volumes. So if I hit the create volume button at the top of this section of the console here, you can see that this pop-up appears. And inside the pop-up there's some useful information actually. First of all, I can select the particular volume type that I want to create. And it states here in the IOPS the areal density of I/O per gigabyte that's available to me. So a baseline of 3 IOPS per gigabyte on the general purpose SSD volumes. And in the case of the provisioned IOPS volumes, if I enter a number here which exceeds the number of IOPS that can be driven through the particular size of volume that I've selected, I'm given guidance about this 30:1 ratio. So the maximum number of IOPS for 100 gig volume would be 3000 IOPS. If I select 3001, you'll see that I hit that same issue again. So you've got 30 IOPS per gigabyte on the provisioned IOPS volumes, and 3 IOPS per gigabyte on general purpose SSD volumes. Encryption of volumes is enabled just by checking the encrypt this volume tag here in this little radio button. And you can see there that I can select from this drop down keys that I've created in KMS in my specific region for this purpose. At the moment I don't have any, so I just have that default key available to me. And creating a volume is just as simple as selecting the options that you want here and then selecting the create button. This volume will go into a create state. And if I refresh the console in just a few seconds, you'll normally see that the volume's available very rapidly. There we are, we already have our 100 gigabyte volume available for us, the general purpose type with that 300 IOPS allocation available by virtue of that volume size. That's really it really, there's not a whole lot more to show here. The next topic area that we're going to cover is networking for EC2. And what we're really going to be talking about here is an AWS service called Amazon VPC. VPC provides a virtual network in your own logically isolated area of the AWS cloud. You can populate this with infrastructure, a platform, and application services as you wish. These services will share common security and interconnection characteristics. And you can find out a ton more about VPC if you visit awsamazon.com/VPC, URL you can see bottom right on this particular slide. There's actually a number of sub-features within the VPC service. ENIs, these are elastic network interfaces that you can attach to instances. They have public IP addresses on them, and you can use these to float those public IP addresses between different instances. That can be a very useful feature. Subnetting, where you lay out your own network topology, and on those subnets you can apply network access control lists. These are stateless filters that will filter traffic flowing in and out of subnets that you create. You have full control over the route table, so you can route traffic from subnets to destinations of your choosing. You can create or not create internet gateways as you wish. You can create or not create virtual private gateways for VPN access to and from your VPC, or to and from selected subnets within your VPC. And you can create Route 53 private hosted zones to provide DNS services within your VPC also. So it's a very capable networking service that allows you to build the network topology and traffic flow and traffic control that you need to within your environment. The topologies are flexible. A VPC itself can span multiple AZs within a region, but each subnet within that VPC must reside entirely within one AZ. You'd have seen this earlier. This is how placement of EC2 resources is managed. When you come to create an instance, you specify which subnet you wish it to be placed within, and those subnets are associated with specific availability zones. For high availability, use at least 2 subnets in different AZs for each layer of your network. It's possible to peer VPCs with one another in the same region. So it's common for customers to do this for building things like service VPCs, where you might put shared security or network infrastructure, services that you want to make available to applications or services running in client VPCs around the outside. That's the topology that you can see there on the right. If you want to learn more about VPC peering, check out the guide that you can find if you click the URL on the bottom right of this slide. There's also quite a number of partner tools that provide additional VPC networking features for things like overlay network construction, network intrusion detection, alternative VPN termination appliances, stateful firewalls that you might wish to use within your VPC. Many of these are available via the AWS Marketplace, and it's well worth checking out some of the partner solutions that are available for enhanced EC2 networking. You can also establish connectivity between what we call classic EC2 instances. So these are EC2 instances that might have been created before the VPC service was available within AWS. Different network topology and layout applied here. And we do have a few customers that still use EC2 Classic. We introduced a service some time ago now that allows you to connect these classic resources to other services that reside within VPCs using security groups and other features. So that's worth checking out. Again, you can find more detail on that at the blog post that I've provided a link to on the bottom of this slide. Another important EC2 networking feature is elastic load balancing. This is a highly scalable managed load balancing service that provides regional traffic management capabilities existing at the regional level and allowing you to dynamically and intelligently distribute traffic across a fleet of EC2 instances that might serve a specific purpose. It's used very commonly for web servers. It's used very commonly for API servers. It's actually used in a variety of other use case scenarios as well. There's some sophisticated features here, things like timeout configuration, health checks, connection draining, and of course the capability to load balance across different availability zones. Probably haven't got time in today's webinar to go into a lot of detail on this, but it is a very capable service, and you can find out more at awsamazon.com/elastic load balancing. Monitoring, metrics and logs. The core of monitoring and metrics with EC2 is another AWS service called Amazon CloudWatch. This is a monitoring service for AWS cloud resources and also actually for other applications that you might run on AWS. You can use CloudWatch to collect and track metrics and also to collect and monitor log files. And you can generate alarms from both of these collection types. The system works and looks a little bit like this. So resources that use CloudWatch and your custom data can be posted into the CloudWatch API and will be collected and maintained there. And you can use these metrics in conjunction with triggers to trigger alarms. You can also visualize metrics through a statistical model that's available via the management console and also via the API if you want to write your own statistics consumers. And the alarms that are triggered by CloudWatch can be used for a variety of different purposes, for things like auto-scaling or for notification. There is integration with CloudWatch within the EC2 console. You can drill into each one of your instances or groups of instances, and you can see monitoring data. Here you can see an example of this where we're looking at network traffic, at CPU utilization, at other important metrics that might be helpful in monitoring or diagnosing performance characteristics or issues, respectively, with your EC2 resources. We also provide reference implementations for some sample scripts that allow you to post application or operating system metrics into CloudWatch. We provide these for Linux and for Windows. They make use of EC2 roles that we'll return to a little bit later to enable your applications or operating systems to post specific metrics to CloudWatch. Examples of this would be things like operating system memory consumption monitoring, something that can't be done from the hypervisor, so it's impossible for us to monitor it within the EC2 platform essentially, but you can post a custom metric which monitors that data, and you could use then memory consumption as a metric for example, auto-scaling or generating alarms. So there's a useful reference implementation here, and many customers have extended this, writing their own monitoring tools in languages of their choice using the AWS SDKs that are available. We also have a log centralization capability within CloudWatch called Amazon CloudWatch Logs. This allows you to monitor applications and systems using log data. We store this in a highly durable S3 storage behind the service, and you can manage these logs using set retention policies, so there's no need to age and expire them. The service can do that for you. And then you can access your log files via the console, via the CLI, or via AWS SDKs. Support this for EC2, for AWS Lambda, and we'll add further services over time. And metrics and alarms and logs are managed similarly in terms of the flow that takes place within CloudWatch. Here you can see metrics data being collected via CloudWatch and being used to trigger alarms, and then those alarms can in turn be used to take actions. And with CloudWatch logs, again, you can use a log filter to generate metrics again, so metrics upon pattern match essentially within your logs. That can generate alarms and you can drive actions from that. And the actions that you can take are pretty varied. You can use them for notifications via SNS, so this is email notification or posting to specific API endpoints that you might create in a pub-sub model. You can use them for auto-scaling actions, which is a very common use case, to scale up or scale down a fleet of EC2 resources. And you can also trigger EC2 actions themselves that might, for example, recover, stop, or terminate an instance on the basis of particular metrics that you might specify. A good example of this might be terminating instances that are consistently unused over a period of time. Security and access control. And there's two different things at play here. The first is key pairs on the right hand side, which we showed you very briefly earlier. So generating a key pair when you create an instance is a mechanism for controlling login. In the case of SSH access on the Linux platform, these are RSA key pairs, public and private key pairs, that are used to authenticate and authorize access to your EC2 instances. You hold the private key and we inject the public key into each EC2 instance via instance metadata. And then access credentials. These are access and secret keys that are used to authenticate when accessing AWS APIs. The access key identifies the requester. The secret key is used to sign requests. So again, using public-private cryptography. And those requests can then be validated by signature verification and obviously a policy applied to permit access to specific API actions as a result of that. We strongly recommend using IAM roles to pass access credentials to EC2 instances over and above embedding AWS credentials in your code or storing them in operating system config files on your instances. And I just wanted to show you a very quick demo of using IAM roles now so you can see how this works. It's a very important feature of EC2 and one that we really recommend that customers use. Done a little bit of setup for this next demo segment. First of all, I've created an IAM role within the IAM console that you can see here, named EC2_S3_role. And this role has the Amazon S3 full access managed policy attached to it. This is a permissive policy which will permit instances that have this role to access all actions on the S3 API and to apply those actions to any S3 resource. And the second thing I've done here is created another instance which is running also in the US West 2 region. It's a T2 micro this time, and it has the role I've described to it attached to it, which you can see here, and the same key pair that we used earlier. So this particular role at the moment has, this particular instance at the moment has the policy that I showed you a second ago connected to it by virtue of this role assignment. And if I SSH into this instance, which I'm going to do here, slightly increase the size of this terminal. So you can see that at the moment on this instance I can perform operations on the S3 API. So if I go AWS S3 LS, you'll see all the buckets that are created within my account are visible there for me. If I then head back into the IAM console and I'm going to detach this policy from this role, so the EC2 S3 role will no longer have the Amazon S3 full access policy attached to it, and you can see that I've stripped that policy there. The instance is still running. I'll just refresh this and you'll see that the IAM role is still attached to the instance. Just this reloads and you'll see that I've still got that same role attached to my instance, but if I jump back into the console again and perform that same operation, you'll see that I'm no longer permitted to carry out that operation on the S3 API, and that's by virtue of the fact that I've stripped that particular policy from the role associated with that instance. And that really concludes this very quick demo. I'm going to wrap up the session now by talking about deployment options, auto-scaling, and cost optimization. So on deployment of EC2, the unit of deployment is the Amazon machine image. These are the base images from which your EC2 instances are created. And these images take three forms. We have Amazon maintained ones. These are a set of Windows and Linux images which we keep up to date, and they are maintained in each EC2 region. We have community maintained armies, which are images published by other AWS users. These are often managed and maintained by AWS Marketplace partners, but they can also be more genuinely community maintained. These need to be carefully vetted and verified before use because AWS do not certify the security of these. They are certified and managed by their providers. And then lastly, your own Amazon machine images. These are armies that you can create from EC2 Instance snapshots. You can keep these private or you can share them with other accounts, even make them public and be a community maintainer in your own right. And the existence of these armies leads to two different deployment models that customers make use of. The first is creating instances from armies directly. So you're starting an instance, you're configuring the instance, you're creating an army from your instance, and then you're able to start new instances from that army. And you have a second option, which is to dynamically configure EC2 instances at creation time. In this option, you're going to be using the EC2 metadata service in conjunction with Cloud Init on the Linux platform or the EC2 config service on the Windows platform to configure your instances. And the metadata service is a private web service that's made available to each EC2 instance that you create. The data that's made available is immutable and is set at creation time. And you can access that from the instance by using the web service endpoint, which is available, as you can see here, on 169.254, 169.254. For all EC2 instances, they'll access a private endpoint that's unique to them. And you can find out more about instance metadata in general if you check out the URL that you can see at the bottom right of this slide. There is a specific area of the metadata called User-data, and User-data can contain encoded data which can be executed by the instances. And in fact, Amazon provided armies include services, the Cloud Init service and EC2 config service on Windows, that will execute the contents of User-data at instance creation time. This can be used for automated instance bootstrapping. For Windows, you can execute script or PowerShell, and it will be interpreted appropriately if it's enclosed in the tags that you can see there. On Linux, you can use any command interpreter that is present on the instance using normal #bang notation to specify the command interpreter, which will then interpret and execute the contents of the user data metadata service. And of course, these two approaches are not mutually exclusive. You can have armies which include prepackaged software, baseline configuration components that you may wish to install, and you can combine this with dynamic configuration using instance metadata. And this allows you to choose where on this continuum you want your particular deployment methodology to fall. Armies, there's significant upfront time in creating the armies in the first place, and there are tools for this such as Packer and other open source tools that customers use to automate Amazon machine image creation. But you do have a more static environment here. The alternative, of course, is to go further down the continuum towards dynamic configuration. Takes a little bit longer if you do large amounts of dynamic configuration at instance creation time, but you do have the opportunity to be more real time and have a lighter weight integration process for your machine images as a result of this. This is a decision that you need to take in light of the particular use case that you have in mind. AMI-based deployment models using images can be particularly advantageous in auto-scaling scenarios. And auto-scaling has two different use cases in the context of EC2. The first is maintaining a fixed fleet size for EC2 instances. And if you do this, you're creating an auto-scaling group and setting the minimum and maximum size to the same numerical value. This scenario will be executed by auto-scaling detecting impaired EC2 instances and automatically replacing them to keep your auto-scaling group at that pre-configured level. Second option is automatically scaling an EC2 fleet so that it follows the demand curve for your applications. And this is done on the basis of CloudWatch metrics, where triggering alarms within CloudWatch will trigger addition or removal of compute capacity. And this is where using armies is particularly valuable, because you want to be rapidly adding compute capacity when an alarm is triggered so that you are responsive to the demand profile that your application describes. There are three components in creating auto-scaling groups within Amazon Web Services within the EC2 service. First is a launch config, which describes what auto-scaling will create when adding instances. This is a one-to-one mapping between launch configurations and auto-scaling groups. The groups themselves are the scaling managed groupings of EC2 instance, where you're setting these minimum and maximum bounds, defining which launch config you're going to use, and specifying where your instances are going to be created in terms of availability zones. And then your auto-scaling policies are the things that perform the scale up and scale down actions. You typically use damping here with this ---- cooldown flag to prevent too many auto-scaling actions taking place within a short space of time. You should give some thought to what is the best type of instance that you can use to fulfill the particular demand profile of your app. Here you can see a representative workload profile for a hypothetical use case. And we're mapping M4 larges onto this profile using 41 instance hours, which is costing us $9.42 per day. We could fulfill the same profile using these T2 smalls. We drive 70 instance hours rather than 41, but the instance hours cost only 2.6 cents per hour, so the aggregate cost for the day's worth of service is $1.82, and that's a 63% saving. So it's a good idea to evaluate the granularity with which you'll scale and make sure that you match that with an appropriate instance type. A little while ago, we announced responsive policies for auto-scaling. And this is a blog post about this at the bottom, but what happened, a link to a blog post at the bottom, but what happens here is you can perform more aggressive capacity addition actions if you pass subsequent thresholds that you define in the responsive policy. Here you can see that if we hit, for example, CPU utilization greater than 80%, we'll add 9 instances rather than the 3 we would add if CPU capacity was at 60%. This is a mechanism for driving more responsive scaling and ensuring that your application needs are met more accurately. Useful resources. There's only one really useful resource that you need to go to learn more about most of the topics that we've covered in this webinar. That's right here, AWSamazon.com/EC2. So very close to running out of time for today's session now. I just wanted to thank you for joining us. I appreciate you spending a little bit of time with us to learn more about Amazon EC2. I'm Ian Massingham, as I said at the beginning of the session, and if you're interested in keeping up to date with activities for an evangelist at AWS here in Europe, you can find me on Twitter, as you can see there. I'm going to turn the session over to Adam now, and Adam's going to close out the session by addressing some of the questions that were submitted during the course of today's webinar. If you do have further questions, please keep submitting those, and Adam will get to as many as possible during the time that we have left. Thank you. Bye-bye.
One of the first questions that came up was relating to snapshots. Whether, The person had asked, currently I use a script that creates a nightly snapshot, but is there a better way to make regular backups of EC2 volumes? Snapshots are a really good way of having a full disk level backup on your system. So if you needed to restore an entire operating system or an entire volume, it's a really good option to make nightly, daily, weekly snapshots, whatever makes sense for you. However, EC2 snapshots, they don't provide file level backup and restore. And to do that, I'd suggest using one of our partners or a third-party utility your standard backup utility that can create file level backups that can provide point in time at the hour or even minute level that you can restore from. Somebody had asked about how to manage virtual machines from the VMware vSphere environment and how to publish virtual machines from VMware to EC2. And to do this, we actually provide a plugin for VMware, for vSphere, that will exist within your vCenter console and allows you to see both your EC2 instances and your vCenter VMs in the same place. From there, it's pretty easy to select the action to import the VM to AWS or even export it back. There's some questions about autoscaling and how do you scale up and scale down your instances based on capacity that's required. So autoscaling is the feature that allows you to grow and shrink your capacity based on demand. And what autoscaling hooks up to is CloudWatch. So there are a number of CloudWatch metrics. We have a lot that are built in, things like CPU performance or CPU usage or network in and out of your instances. You can also publish custom CloudWatch metrics. So if you wanted to count how many active users were on your system, you could publish that as a metric. From there, once you have that metric, you can use CloudWatch alarms to automatically grow and shrink your autoscaling group based on whatever thresholds you define in that metric. So if you know that once you have 100 users on your website, you need to add a new server, that could be a metric that you use to grow and shrink. Somebody had asked about instance store versus EBS storage, and if there's any pros to using instance store. Now, instance store is available on some of our EC2 instances, and what it is the disks that are physically attached to that instance itself, as opposed to EBS, which is a whole different service that provides access over the network. Now, instance store is great when it's available because it is included in the price of your instance. So if you have an application that is just writing temporary data or is loading something or operating on data that doesn't need to persist between reboots or past the lifetime of the instance, instance store is a great way for temporary storage. However, we suggest you use EBS for any data that is important to you because it has durability. When you stop and start an instance with EBS storage, that data will still be there, whereas instance store, it might not. Along the same lines of instance store and EBS, somebody had asked, how do you pick which data is stored on EBS and which data is stored on instance store? And when you go to launch your instance, you'll have the option at the storage screen to choose whether you're adding an EBS volume or an instance store volume. From there, you'll see the path that will show up as, where it's mounted on that instance. Now, once the instance boots, if you're using Windows, you'll see a new drive or a new disk in the device manager that is the instance store on that path. Or on Linux, you can just see the block device that matches what you added on the EC2 console. Another question was about magnetic storage and what that means. So magnetic storage is your traditional spinning disk. So it is a platter with a spinning disk, and it's a storage mechanism that it was one of the first storage available on AWS, and it's different than an SSD storage. So magnetic is good for any application where you don't require significant performance. But we feel that our general purpose SSDs are great all around general purpose volumes. So they give you burst capacity so you get the performance you need when you're booting the operating system. And then you earn credits that you can use whenever you're doing disk operations. We also recently announced two new storage mechanisms called the storage throughput and cold storage volumes on EBS that can provide streaming storage or archival storage at a very low cost point. Mark had asked, can I copy a snapshot or data from an EC2 EBS volume from one AWS account to another? And that's definitely possible using the snapshot feature of EBS. So if you have an EBS volume that you want to share with another account, first create a snapshot of that volume. Once you have that snapshot created, you can go into the properties of that snapshot and choose share. From there, you simply type in the account number of the other account you want to share it with, and it'll be available to them if they search for that snapshot ID. Once they have it, they can create a new EBS volume, they can mount it to an instance, they can do whatever they need to that volume. Somebody had asked about auto-scaling and how to work with AMIs when you use auto-scaling. So to use auto-scaling, you do need to, we suggest you make an AMI of all of the software installed on your instance. So boot your instance first outside of the auto-scaling group, install Apache, Nginx, whatever software you need on it, and then create a new AMI from that. From there, you can use that AMI in your auto-scaling group and decide how you want to deploy your software for that. So maybe you want to download just the code for your application once that instance boots, and that's an option. And I think I have time for just one more question. Somebody had asked about creating AMIs and creating snapshots. And with the snapshot process, because you're only charged for the deltas of those snapshots, do you have to worry about deleting old snapshots that might have that? And the answer is no. So because with snapshots, we know all of the snapshots that are in your account and what data is backed by those snapshots. So even though, when you make a new snapshot that maybe you only change 50 megabytes of data, you're only charged for that 50 megabytes because that's all the new data stored in that snapshot. We know all of the other pieces of data that are in all of the other snapshots. So that whenever you delete the previous snapshot, even if you leave just one, it will have all of the data you need to turn that snapshot into a volume. And that's all the time that I have today. Thank you again for joining, and don't forget to vote.
Thanks a lot, Adam, for a great presentation. I'd like to thank Ian as well. And I'd like to extend a special thank you to our moderators, Hubert and David, for their time answering the audience's questions. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS will cover in future webinars, please feel free to send us an email at aws-webcasts@amazon.com. Again, that's aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thanks to our audience for taking the time to join us today, and enjoy the rest of your day.